We're now in section 2. Section 2 is rationalising the denominator. So you've hopefully heard this phrase before, but all it means is the technique to help us divide by thirds. So, for example, if I had 2 divided by 3, well, we've got a method for working out what that could be as a decimal. So we could do a bus stop, how many 3s in 2, none, how many 3s in 20, 6, how much left over, 2, how many 3s in 20, 6, 2, etc. Yeah, so bear that in mind. However, if I was doing 2 3, 2 divided by 3, well, I can't really use this method. That's quite a tricky thing to say. How many root 3s are there in 2? Well, if I knew that, I would know this answer, wouldn't I? So dividing by thirds isn't a nice thing to do. So instead, we prefer the bottom of our fractions to be real numbers, integers if we can. So, well, let's look at that 2, 3 in a bit more detail. So we know with fractions, if I times the top and the bottom by the same thing, the fraction remains unchanged. So if I times this by 5 and times this by 5, it's still the same fraction, because it'll give me 10 over 5 over 3, which would simplify to give me the same fraction. So the trick is spotting a good number or a useful number to times the top and bottom by to get rid of the third in the bottom. Well, if you remember, root 3 times root 3 gives me 3. So that means if I times the bottom by root 3, I need to times the top by root 3. So that will give me 2 root 3. That's it. So if I have root 5, I'll times top and bottom by root 5, etc. Let's have a look at what I could do if I have something like this: 1 plus 1 over 3 plus root 2. Okay, let's try doing some simple things. Let's try times in top and bottom by root 2. So on the top, I'll get root 2. On the bottom, I will get, well, root 2 times root 2 would give me 2. But this first term, 3 times root 2, would give me 3 root 2. So I still got a third on the bottom. That hasn't helped. Okay, looking at the last example, you might think, well, if I just times it by itself, that will work. So let's see. Well, on the bottom, I'll have 3 and 3. So we get 9. 3 and root 2, so it's 3 root 2. Root 2 and 3, so another 3 root 2. And root 2 and root 2, so a 2. Oh, okay, well that's now, when I times by root 2, that turns into a real nice whole number. However, at the bottom, it's going to simplify to 11. So that's 6 root 2. So I've still got a third on the bottom. In fact, I've got a third in bigger numbers than I started with. And I've got a third on the top as well now. So instead, the trick is to change the sign into something like that. It's because if I hadn't moved it out, you would have seen that the two terms in the middle, the 3 root 2 and a 3 root 2, if one of those was minus, it would cancel out. So at the top, we're going to get 3 minus root 2. And on the bottom, you get 9 plus 3 root 2 minus 3 root 2. And root 2 times minus root 2 gives me minus root 4, which is minus 2. Now these cancel out. So I'm left with 3 minus root 2 over 7. Or if I want to write it as 2 separate bits, I could have 3 over 7, take away 1 over 7, root 2. Yes, so now, much nicer, I've got a whole number on the bottom, 7. Okay, let's look at what we have when we have something like root 5 plus root 2 over root 5 minus root 2. Okay, well, We know we have to do something about changing signs. So remember, it's the bottom we look at. So look at the bottom, and it's this one. So root 5, change sign to root 2. Now the mathematical name for doing this when I'm changing the sign, this is called the conjugate. So this is the conjugate of this. Just change the sign in the middle. So I have to times the top by that as well. So then just expand the brackets. Remember, everything's in brackets. There's always brackets, invisible brackets on fractions. Root 5 and 5 gives me 5. Root 5 and root 2 gives me root 10. Root 2 and root 5 gives me root 10. And root 2 and root 2 gives me 2. On the bottom, root 5 and 5 is 5. 5 and root 2 is 10. Minus root 2 and root 5 is minus root 10. Minus root 2 plus root 2 is minus 2. So on the top, 5 and 2 makes 7. Plus, and I've got 2 root 10s, not root 20. Remember, I can't add the numbers. I've just got x and x and 2x. So root 10, root 10 is 2 root 10. And on the bottom, these cancel out. And 5 minus 2 is 3. So I can write that 7 over 3 plus 2/3 root 10. Very well do. And that's all there is to it. So have a go at the questions now and see what you can do.